started right away. So a bunch of weeks, well, not a bunch of weeks ago. Actually, yeah, because this was before Christmas break even.
Oh my God.
But if you look at the problem, when you look at number 2, question D, it references Euler's method, which we learned a while ago. And if you guys recall, Euler's method was those charts. You guys remember those charts? Yeah. Okay. So Euler's method was dependent on having a starting x value and y value. That was typically a point they gave us. And then they had the delta x or the h. It could have been either variable. And that was the step size. And if you guys remember, we used this process on it where we were finding like the little itty bitty lines. And then we were getting a new point, using a new point, plug it in, use another point. And if you guys remember, if we wanted like the 5th number, we had to do all 5 of them, right? So if you look at number 2, part D, it says to use Euler's method for n equals, or actually, no, it says to estimate the population after 50 years. That would mean you have to do this process with a chart 50 times, 50 rows.
No.
Terrible, right? We're going to write a calculator program to do it for us, okay? I did some research. I looked this up for you guys.
Thank you.
You're welcome. I care about you. I was like, we're not doing this 50 times. So let me hand that out, actually. Okay, I don't want to spoil the answer. So if you look at the problem, they gave us some information. They said that the initial population is 1,000, so we know that we're starting with the point 0, 1,000. So we know what our initial x is and our initial y is. We know that we are using a step size where h is 1. That's the same as delta x from what we did before. And we know that we're doing it for 50 years, so we know we're looking at for where n equals 50. Okay? So on here, the first thing we have to do is program our calculator. Here are the instructions. So to program your calculator, you're going to hit the program button. Right there, it says program. Everyone see program? Hit the program button. You're going to go over to new. Yours should not have any because your calculators have probably been cleared a lot. I practiced this earlier, so mine already has one. So go over to new, press enter, and it's going to ask you to give it a name. You're going to call it Euler. So E-U-L-E-R, E-U-L-E-R, and press enter. Okay, hold on. I'm going to go ahead and clear that program I spent so much time making. It recognized it. It was like, I know what Euler is. No. Okay, so the first instructions for your this is the program exactly. All you have to do is type this in with no typos and you'll have it exactly right. Okay, so it says display first x. We're writing essentially a computer program. We're just doing it on a calculator. Okay, so display first x. This is kind of like asking you what the first x coordinate is. It's like if you look at the chart and we had the old x and the old y. So we're telling it what the old x is, what the old y is. That's what we're programming into the calculator. So DISP is for display. So if you hit the program button and go over to where it says I/O, input/output, that's what that means, then DISP is number 3. So display. The next part is quote first x. To get the quotations, we're using the alpha button. So go ahead and hit second alpha. We want to lock that so we can type in a few things all at the same time. The quotes are above the plus button. So you're going to type in plus, and then you're going to type the word first using your alphas. So F-I-R-S-T. So type in first. The space button is right above the 0. If you see it, it looks like a little horizontal line. That creates a space. Then we're going to type in X, and we're going to put the quotations. So that's what should be on your calculator right now. Do we have it? So now you're going to press enter to get to the next line. And now it wants us to type input X. So we're going to hit the program button again. We're going to go down to I/O, and input is number 1. So input, and then alpha X. And then we're going to hit the program button And we're going to go to display. Now, my program didn't work when I first did it, and it was because I had a typo. So just make sure you're being careful as you go, that it looks exactly the same as what is on your paper. So you're telling the calculator, display this on the screen, and it's going to display first x on the screen, and then I'm going to tell it the first x is 0, and then it's going to input it for x. So what we're going to do is we're going to go into the y equals screen, and we're going to type in a function. And so you're telling the calculator, when it does this and I give you a number, put that in for x. Yeah. And now it's going to say when it displays first y on the screen, I'm going to give you a number, then you're going to input that in for y for me. And then we're going to do display. If you want to call it h instead of delta x, because this program happens to have an h, then you're welcome to put that if you want. I'm going to go ahead and use delta x. And then now, if you change this, are you guys listening? If you change this from delta x to h, then you're going to have to put h's everywhere else that has a d. Okay, so just if you decide to switch it, just keep that in mind. You're going to have to switch other things. So I'm going to go ahead and keep it the same for those of us who are careful. Now, to get the next part where it says label, I want to say, I found it earlier, I want to say it's in the first, yeah, there you go. So you don't go over to IO, you keep in the first one that I believe means control. And it's number 9, so label 1. So what we're saying is we're putting all of these things in and we're labeling this is the first number that you get. Okay. Now, this is us doing the part, if you look at your notes, if you can see what we're doing, we are programming the part where we are telling it, do this math, and that gives you the new y coordinate. And if you can see after label, that's what we're programming it to do. Okay. Does anyone remember where y1 is? We've used it before. Plus, nope. Vars, yeah, hit vars. Go over to y vars. Hit function. And then there it is.
Store?
Yep, to get the arrow, you hit the store button. The arrow is that store button. It's right next to the 4 and the 1. So we are saying, here's what we're telling the calculator to do. The arrow is that store button, which is by the 4. We're telling the calculator, perform this operation and then take that, put it in as the new y. And then do it again. That's what makes it kind of loop through and like do the same process repeatedly. And then we're saying, okay, to get the new x value, you're going to do x plus d, and that's going to become the new x.
What did I just do? If I hit clear, will it clear everything?
It will just clear the line you're on.
Oh, I have a question.
Mm-hmm.
If you have a transmitter cord from one calculator to the other, can you just put this on another calculator?
You can send programs to other calculators.
So you're just
Now this part down here, when I'm telling it, I'm saying display, and I'm telling it to display an X on the screen, like literally display on the screen the letter X, and then I'm telling it to display X down here. I'm saying now put X on the screen, and then put the number from the calculator. So I'm telling the calculator to display it in a way that's easy for me to read and recognize. So it's going to, instead of just telling us the x and the y coordinates, it's going to have a letter x and then tell me the x coordinate. It's going to have a letter y, tell me the y coordinate. Yeah. Yes, and that is, I don't remember where that is. Give me a second, I'll get there. So the pause. Oh, the pause is number 8, right above label. Is go to on there as well? Yep. Okay, so you just have to have it typed in there exactly the way that it looks. And then we're going to go ahead and we're going to quit out of this. When you have it completely done, you're just going to hit second mode, so you're going to quit out of that. We have to go into the y equals screen, and we have to tell it which differential function we're doing this for. So number 2, that was the equation that we had, was this one right here. And remember, it's dy dx, so these p's are actually y values. So you're going to type 0.0015, and then you're going to use your alpha button to put a y in there. And then 1 minus y divided by 6,000. So we're making sure that we're typing it in using x's and y's, and in this case, we're happening to use y's. Now you get out of that, you quit out of that. And I believe you have to do this next step. Actually, let me try it real quick. Well, hold on.
This is scary.
Woo. Oh, it works. Okay. So, okay. So once you've typed that in, go ahead and X out of that. Now we're going to hit the program button again. And this time, we're not going to make a new program. We're not going to edit the program we already have. If you hit edit, it will allow you to go back through and retype things. We're going to hit execute. We want to use the program. So it's going to say program Euler. You press enter. And now it's going to ask you what's the first x value that you're using. And the first x value that you're using is 0. Now it's asking you for the first y. We're using 1,000. Now it's asking us for our delta x. That's the same as our h value, which is 1. Okay, there's our first number. Did everyone else get this? Yes?
Yeah. Oh,
There's our second number. Guess how many times we have to press enter? 50. We got to press it 50 times. But pressing enter 50 times is way better than doing 50 lines of a chart, right? You don't have to count because it's telling you the x's. So I'm just going here. Some of your calculators are going to be able to do this faster than others. I believe those of you with the color calculator might have to go slower. Your calculators take a little bit longer to think. Yeah.
Oh my god.
Isn't that fun? That's so much more satisfying than doing a chart, right?
Oh no. They won't only do
I found that if I pressed enter too fast, it seemed to like stress out my calculator. So be careful that you don't stress your calculator out.
How do we know when we
Because it's telling you the x value. It's telling you how many times you're going. And the reason it's displaying this number, do you guys see this part? How it's displaying the x and then giving you a number and then displaying the y and giving you a y? It's doing that because we told it to display an x on the screen before it told us the number, and display a y on the screen before it told us the number. So that's what we programmed in there. We made it do that to make it easier for us to know what it was saying. So for the 50th, you should have 1,064.039. That was the actual answer for number 2, part D. Okay?
My computer, my calculator died. Your computer.
Oh, forgot.
Now, it actually, if you look at my calculator, this is a good point. Do you guys see how my calculator is doing the thinking dots?
Yeah.
I left my calculator on last period, and it literally thought all period, and it never stopped. So if you want your calculator to like do something else after this, you're gonna have to turn it off. Do like second on, like turn it off, and then you can like let your calculator think again. To see what your calculator did. Yep.
I'll go there because that's the.
Okay, so when you work on number 11, that problem had, I might just put this up on the screen. So number 11, are we ready? Number 11 had this part, and it's saying, explain the meaning of the minus 15 on the end. So it's just saying all this stuff, like how we've normally done our population, that's still going to be the same. It just says subtract 15. This is telling you that this is our rate of change, right? We're losing 15, and that's a constant. We're not multiplying that by anything. That's a constant thing. So we're losing 15 fish for whatever the time period is. Since this is referencing an example that you guys didn't do, example 1 in this book, are we listening? Since we're referencing example 1 in this book, we don't know what it is. We can't say what the time is, but we do know that whatever it is, it's in terms of fish. So you're losing 15 fish for however long the time periods happen to be. It could be 15 fish per year if it was years, or for 15 fish per day or week or whatever. That's what it's saying. For this next part where it says draw the direction field, I always found my equilibrium solutions first because that helped me know where my dotted line, where my horizontal asymptotes were. So I did C next, and I looked for the equilibrium solutions. So if we think about it, if there was no 15, how would you find the equilibrium solutions?
0 and 1,000.
Yeah, it's 0 and 1,000, and that would be because this is factored form, and if I solved this for P, it would equal 0, right? This is a quadratic that has been factored, and you'd set it equal to 0, and that's where you'd find your equilibrium solutions, and it would be 0 and 1,000. Now, if I put a minus 15 on the end, are those solutions going to be the same? No. So what this is right now, this is the part I'm going to make you do on your own. I'll tell you the answer in a little bit, but I'm going to make you do it on your own. This quadratic right here equals 0, and for you to find equilibrium solutions, you have to solve it and set it equal to 0. You can do that by factoring. You can do that using the quadratic formula. It's up to you. Okay? So take this whole thing, make it equal 0, solve for P, find your equilibrium solutions. All right? Go ahead and work on that. Okay, so there's the math right there that I did. So quadratic formula, P is 250, P is 750. How does that help us go back and do part B?
You gotta do the thing. Yep.
equilibrium solutions.
Yeah, those are where it's flat.
Those are where it's like got a slope of 0, completely flat. So now,
too, apparently not. Wrong. Oh, it's 0 to 250 and
It's-
250 to 750.
yeah, and it's not 0 because the 15 throws it off. Yeah. So we're gonna go and we're gonna draw our picture. So 250 and 750. If you plug in 500, it looks like you get a slope of 5. So that's pretty steep.
That's crazy. Oh, and since the y doesn't matter, follow all the way across.
Yes. If you plug 0 in, you actually get negative 15. Yeah. Isn't that interesting? And then if we plug 1,000 in, get negative 15 as well.
Yes.
And then if you wanted to get some more numbers in there to see a better slope field, we know enough about slope fields, right, to know that these would be a little bit less steep, right, but still increasing, because this is the logistic function part of it. Okay. All right, so there is your picture right there, and then we do also, part D said to draw some specific solutions. You can skip part D. So if you have A, B, and C, that's fine.